Hi guys, so we are finishing up functions. So the last thing we're going to do is talk about rational functions, and that means that we are talking about functions that are big fractions, okay? And the way that I remember that is that the word ratio is in rational, and a ratio can be written as a fraction. So that's how I remember that whenever I see the word rational, it means fraction. Okay, so there's a couple definitions. What we're going to start talking about are asymptotes, and what those are, they are imaginary lines that the graphs will never cross. And we have talked about like exponential and logarithmic. Those actually have asymptotes, but we just hadn't talked about an asymptote yet, okay? So we are going to point those out with the logs and the exponential that we've already been doing, but in this case, these rational functions, they've got very obvious asymptotes, and in order to graph them correctly, you have to recognize those asymptotes so that when you draw those curves, you definitely don't cross those imaginary lines. And you'll see what I'm talking about, okay? So to find the vertical asymptote, okay, up and down, that means it crosses the x-axis. So it's x equals, and we set the denominator equal to 0, and we solve. Okay, and I'll show you what we're doing when we get there. And then for horizontal asymptotes, that means it's the line that goes this way, so it crosses the y-axis. So it's y equals. And if the higher x power is in the denominator, then it's 0. If it's not, then you divide your x's, and it's whatever you get. And I'll show you what we're talking about when we get there as well, okay? So let's look at a couple of problems. Alright, and let me make sure. Okay. Let me put this here. That way I know not to draw that. Okay, so I do use my graphing calculator a lot for asymptotes, or excuse me, for just the curves of our graphs. That way we just kind of know which corners we're curving in, and sometimes we've got more than one corner, or we've got more than two curves. So we are going to use the graphing calculator to kind of get the shape, but then we can actually use the numbers of our problems to get the actual asymptotes. So, all right. So let's look here. We've got y equals 4 over x minus 2. Well, if we want to get the general shape, okay, we can put this into our calculator and just always remember, put parentheses around your numerator and around your denominator, and then your calculator will be careful. So, let me pull up the calculator. Alright, so the general graph would be parentheses 4 divided by parentheses x minus 2. Okay? And so this is going to give us our general graph, okay? So if you notice, it curves in the bottom left corner and it curves in the bottom right corner. And that vertical line that we see, that is actually the asymptote. That is the line that actually isn't a part of the graph. That's that imaginary line, okay? So what we want to do is we want to find out exactly where that is. Okay, well, in order to find that, and set it up above, what you do is you set the denominator equal to 0. So if you say, okay, well, since, and the way my class and I thought about it last year was that if you're looking for the vertical asymptote, look horizontally at your equation. So if I look horizontally, I say, okay, well, this means that x minus 2 equals 0. Okay, well, if you were to solve that, it's kind of like factoring and solving, add 2. That means x is 2, and that's that vertical asymptote. If you're not exactly sure, you just kind of look at the numbers here and get the exact number, but that vertical line is at 2. So technically, we should actually do a dotted line, because it's an imaginary line. The graph actually isn't a part of that. That's where it doesn't cross. Okay, and then it also doesn't cross right here. This one curves here, and this one curves, and it looks like it doesn't cross the x-axis, but the way we double check is we divide the numerators. Well, we divide the x's of the numerators. Well, since I don't have an x here, and I do have an x there, you can't divide it. So if you can't divide it, if you don't have an x on top and an x on bottom, then it is always 0. So the horizontal asymptote right there, that line that graph is not crossing right there, is the x-axis. That's where y is 0. And then the actual graph is just, let me get a good marker, is just a curve off to the right, top right, and a curve off to the bottom left, okay? So these dotted lines are telling us the limitations of our curves. They approach, they get super close to those dotted lines, but they're never going to cross them. So the graphing calculator gives us the shape, and then actually working out some of the numbers gives us the exact numbers, okay? And then we've got end behavior right here. And we've got increasing and decreasing right here. So end behavior, as the graph goes off to the left, because that's negative infinity, what number are we coming close to? Well, this side is coming close to 0. Because, remember, it doesn't cross 0, but it comes close to. Okay, so y is 0. And then as we go off to the right, as this side goes off to the right forever, okay, it's also going to come close to that that horizontal asymptote, so it's 0. Okay, so if you notice, these two have to do with the horizontal asymptote. Okay, because we're talking about the y value, f of x is the same thing as y. Then since our y value here is 0, then it's approaching that 0, but it's not going to cross it, okay? And then increasing. Well, if you look, is this curve increasing? No, it's going down. If you go left to right, this one's going down. And if you go left to right, this one's also going down. So there's no increasing. So you could say empty set, or you could do those empty brackets, okay? It doesn't work. There's no increasing. But decreasing, this one, as it goes from left to right, it is going down, okay? But the breaking point, instead of a turning point, like we have on other graphs, this actually has a breaking point. It's actually split into two sides. So this side is from negative infinity, and then it approaches, so from negative infinity on the left, and it's approaching this line, which is a 2, but it doesn't cross it. And then it breaks, and then it starts back super close to 2, and it goes down forever off to positive infinity. So from 2, this side is 2 to infinity, and this side is negative infinity to 2, because it's starting off to the left, and it gets close to 2. This is starting at 2, and it goes off to infinity. And if you notice, and then there's a union right there, they're both going down. But if you notice, this 2 right here is the same thing as this vertical asymptote that we got up here, okay? So these two, and it's because the intervals, remember, we're looking at the x values, so that's why the x equals relates to it. And then the end behavior, we're looking at the y values, so that's why the y equals relates to it, okay? So there's a bunch of connections here that we'll keep talking about and keep practicing. All right, so there's that. So let's do the same thing for the other one. Oh, and I guess you can see that. I'm sorry. All right, so let me move my calculator over. And again, we can use the calculator to graph. Just put parentheses around the top and around the bottom. So it'll give us our shape. Y equals parentheses x and parentheses x plus 1. All right, so here is the general shape. It's actually the other corners, top left and bottom right instead. But we need to find out what this line is, and we need to find out where it's not crossing here. So we have the curves. This one is curving, and this is curving. But we just need the details, okay? So to get those details, what we want to do is, to get the vertical asymptote, we want to look horizontally. It's opposite, they're opposite of each other. So to get the vertical, look horizontal. So x plus 1 equals 0. So when you subtract 1 from both sides, you get x is negative 1. So this line right here that it's not crossing is negative 1. So we're going to put an imaginary line at negative 1. That way we won't cross it, okay? And then remember, to get the horizontal asymptote, you want to look vertical. They're just, you kind of reverse them from each other. And you divide those x's. Okay, so to get the horizontal asymptote, you say, okay, well, what is x divided by x? Well, that's 1 divided by 1, so that's just the number 1. So that's y equals 1, because we're talking about horizontal, so that's, excuse me, we're talking about horizontal, so that's going to cross the y-axis. So this line right here that it's not crossing is at 1. Okay? So those are our two asymptotes. So we can do the curves just like we see them, but now we've got the details down so that our curves are fully accurate, okay? So the top left corner and the bottom right corner. Okay, so that is our graph. So we got the curves from the graph, but we got the exact asymptotes from looking at the details. Remember, if you're looking for vertical, solve horizontally. If you're looking for horizontal, solve vertically. Go up and down, okay? All right, so now remember, the end behavior relates to the y value, okay? Because f of x, remember, it stands for, it's the same thing as y. So since we're approaching 1, then we're actually going to approach 1 in our end behavior. As we go off to negative infinity, as we go off to the left, it's coming close to that 1, that y equals 1. And as we go off to positive infinity, as we go off to the right, this is curving up and it's coming close to that 1. So, as we go to the left, the function's approaching 1. As we go to the right, the function, or the y, is approaching 1 as well. All right, so then we do increase and decrease. Well, is this curve increasing or decreasing? It's increasing because it's going up. This is also increasing because as you go left to right, it's going up, okay? So there's no decreasing. Well, let's fix that. Okay, there's no decreasing, but there are two intervals of increasing. So this left one is coming from negative infinity, and it's curving up and approaching negative 1, but it doesn't cross negative 1. There's a breaking point, okay? This one is starting at negative 1. It's starting very, very close to negative 1, and it goes off to the right forever, which is infinity, okay? So these are two different intervals, and they're broken up because of that asymptote at negative 1. So from negative infinity to negative 1, from negative 1 off to positive infinity, since they're both going up, and they are in union. And remember, I'll write it one more time. This has to do with our vertical asymptote, because we're talking about the x value when we do intervals. We're going left to right, so that x value up here relates to those intervals down there. And then, where's the marker? Here it is. And then this relates to our horizontal asymptote, because we're talking about the y value. So we're talking about what is the y doing? What are we coming close to with y? Okay, so just remember that there's a relationship with our asymptotes to that behavior and those intervals, okay? All right, so we'll do a couple more, and we'll talk about the backside. It's the same thing, but there's just more to it because there's a little bit higher powers, okay?